All right, on to the last part here. Today we're going to be talking about Leibniz's notation, which is the dy dx form. Okay, so we go interchangeably. We use f prime of x or dy dx all the time. It doesn't matter. We can do them back and forth. They're just different kinds of notations. So dy is called the differential of y. Okay, it's differential. It shouldn't be too tough. And then dx is called the differential of x. So both of those are finite terms. All right, it's just like way back when you did slope, right? If we were trying to find slope of this line here, we would do the change in y over the change in x. So that's similar to what this dy dx is. All right, these are both measurable, so this is something that could be useful to us. So technically, though, the dy part is from that point on our tangent line, from the x value we're looking at, all the way down to the y value of the first x value. That sounds confusing, I'm sure. Sorry. It's not too bad. Just look at the picture. Let me erase some of this here. All right, it might be easier in practice too. So when we look at this, the delta y, the change in y, the measurable quantity, is the difference from this y value to this y value. The dy, because we're looking at a very small area when we talk about slope, the dy is the difference from the tangent line to this y value. All right, and so then one more thing, normally we write it as dy dx, okay, but if, this is just another way, if we multiply both sides by the dx, all right, or if we take a derivative, so if we, for example, have y equals x squared, we could write dy equals 2x dx, okay, that's like our implicit differentiation before. And so this is just another way of writing it. This is called the differential form of the derivative. All right. So find the derivative of each function in differential form. So I'm going to just write it like we did before. Dy dx equals, take the derivative, 6t squared plus 5t minus 3. The only difference, I guess I would have to do dt, wouldn't I? The only difference now is instead of writing the dt there, it's like we're multiplying it on the other side. Okay, so it's dy equals that dt. All right, so this one's going to be dz, and here we'll have to do the product rule first, times the derivative of the second, which will end up being, what, 3 cosine of 3x, plus the second times the derivative of the first. So we're going to have 3x squared, sine of 3x, and the last thing we'll have is dx. Okay, so that whole thing is times dx. The last part, again, we're going to take the difference of this, but it's not too bad because it's an exponential. So we have dm equals e to the 5q squared plus 1 times the derivative of the top, which will be 10q, and it's that whole thing dq, because that was the variable. So just another way of writing this. So this is a reason why it might be useful, and it'll become really useful in our next section. A machine spherical bearing. So hopefully you guys know what a bearing is. It's just it's a sphere. It's this little thing used to help things rotate or whatever. All right. It's so that we're measuring it. The bearing's radius was found to be 2.3 inches. So I'm going to just write that down, 2.3 inches. With a possible error no greater than this much, okay? What's the maximum possible error in the volume of the spherical bearing if we use this measurement? So the error that we have, that's the error for the radius, all right? And so how would a change of that much affect the change in volume? That's what we're trying to figure out. So notice I said change. All right, so the change in the radius, or dr, okay, the derivative, when we talk about change, we're talking about calculus, is 0.0001. So we have a volume, and we have the change in volume. This is what we're trying to find, the error in the volume. All right, so hopefully you remember what a sphere, the volume of a sphere is. It's 4/3 pi r cubed. Take the derivative of that. It's 4 pi r squared. So I'm going to write it in the other notation. All right, dv equals 4 pi r squared dr. Plug in the values that we have. Actually, I want to write this so you can see it. All right, so when x equals 2.3, this is going to be a good habit. dv equals 4 times pi times 2.3 squared times dr. And if you plug that into your calculator, I believe you get this number, and it would be cubic inches because we're talking about volume. So with an error of this, we have an error in our volume up to this. All right, so we'll be using these kind of problems. The next section is called related rates, and we're going to be very, you have to be very specific. You have to list out what you have, what you're looking for, and it won't be too bad. Okay, I think it's a lot more fun than this unit is, but that's okay. All of it's fun, but the next one's more fun. Okay, so please just complete your whisk and have a great day.